right, so first is really just a question to make us think for a moment. So a friend wants to play a simple coin flipping game. If the coin lands heads up, you win. If it lands tails up, your friend wins. Suppose the outcome of 5 plays is 5 tails. Is your friend cheating?
Yes, absolutely.
You guys are 100% convinced you do not trust your friends. They must be cheating. So what's the probability of getting a tails?
1.5.
1/2 or 0.5. And so that would happen 5 times. So you can either write it out 5 times or do to the 5th power.
Oh wow, that's probability.
So if we do this, 0.5 to the 5th, the odds are 0.03125. So is it impossible?
No.
No. Is it likely? No, this is considered unusual. So this is very unlikely. Either our friend is lucky or cheating. Okay, but how many times would our friend have to win in a row before we were convinced that they were cheating? Do we have a set number in our heads? 10. If they win 10 times in a row, we are 100% convinced they're cheating. That's kind of what hypothesis testing is. We know unusual things can happen, right? But we are trying to figure out, is this really something that could happen in this scenario, or is there some other information going on? So a hypothesis is any statement regarding a characteristic of the population. When we go through this, the first thing we're going to talk about is writing a hypothesis. And ours are going to be very simple. It's just going to be the mean equals whatever, or the probability equals whatever. Very straightforward. For example, in 2008, 62% of American adults regularly volunteer their time to charity work. A researcher believes this percentage is different today. So, it was 62%. What does the researcher believe? It's different. So his hypothesis is that it has changed. According to a study published in March 2006, the mean length of a phone call was 3.25 minutes. A researcher believes the mean length has increased. So the hypothesis is that the mean is increased. Okay. What we are going to do when we're going through hypothesis testing in the next few weeks is kind of a series of steps. But keep in mind, this is only useful if I don't have the population data. If I can pull all cell phone records in the US, could I find the mean length of a phone call? Yes. So would I have to guess if it was more than 3.25 minutes? No, I could find it out. So we're only doing this when I can't access the data for everybody. So if we have the population data, there is no need for this. This is inferential statistics. We are taking some information that we have and trying to extend it to another group. So this is a case when we don't have all the information and we are trying to make some kind of assumption. So hypothesis testing is basically just used to test a statement. What we're always going to do is make a statement. We're going to write our hypothesis. We're going to collect our evidence, which is like finding the probability of something happening. And then at the end, we're just going to write a basic sentence. I reject the hypothesis, or I have evidence to support this. Today, we're going to focus on 2 things: a null hypothesis and an alternative hypothesis. The null is H sub 0. The alternative, we are going to that H sub 1. So the null hypothesis is what we believe to be true from the past, or what we've seen in the past. The alternative is what we are trying to support, what we believe. when we're looking at this, the null hypothesis is always assumed to be true unless the evidence indicates otherwise. So the null is our assumption. We are assuming this is true, and then we'll see if the evidence tells us it's not. There are three different scenarios here. Every time the null hypothesis is just going to be something equals something. The alternative will either be less than, greater than, or not equal to. So, we call these left-tailed, right-tailed, and two-tailed. So, you'll notice on all cases, the null is that something equals a value. If it's two-tailed, it's not equal. That means if it's two-tailed, I'm assuming it's here, and it could be bigger or it could be smaller. So that's two-tailed. So if it's not equal, that's a two-tailed test. A left tail is when we are testing less than. So if I want to check if it's smaller, that's to the left. We call that a left-tailed test. If I want to check if it's bigger, bigger is to the right, so that's a right-tailed test. But every time, the null hypothesis is the same. So the null is always an equal to. When I say the parameter, that's like the mean, or the standard deviation, or the p-hat, whatever the variable might be in the problem. But the mean equals something, or the p-hat is equal to a value. The alternative, we can say it's not equal, it's less than, or it's greater than. So first we're just going to look at an example and practice writing the hypotheses. And then we'll identify which type of test it is. In 2008, 62% of American adults regularly volunteer their time for charity work. A researcher believes it's different today. So the null hypothesis is always a variable equals a value. If I'm talking about a percent, what do you think my variable might be? The p's. Yeah, we could call it p-hat. A lot of times in this it's just called p, but it's the same thing. So my p is equal to 0.62. Then my alternative, we label that h sub 1. The researcher believes it's different. So that would be not equal. So what type of test would this be? Left, right, or two-tailed? I didn't ask for it, but if I did, the parameter, when I ask what the parameter is, that's just your variable. So in this case, that's p. We were testing the p here. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes the mean length of the call has increased since then. So we have to label the null h sub 0. That's always the equal to. What's my variable here? We're talking about the mean, so x bar or mu. We could do either. Equals 3.25. The alternative, what does the researcher believe? It's increased, so greater than. So is this left, right, or two-tailed? greater than is bigger, so this is a right tail test. What is the parameter here? C. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. So, the null hypothesis, what is my variable?
Well, standard deviation is under
Sigma.
Oh. So look, it's an O, so therefore it's sigma.
So it's always equal, so 0.23. The alternative, what does the researcher believe, or the manager believe? Decrease, so less than. So is that left, right, or two-tailed? And what's my parameter? Standard deviation, yeah.
What is a ring? What is a what?
All right, are these okay? The second thing I want to talk about today, so we've talked about a null and an alternative hypothesis, is error. So with hypothesis testing, we are not going to be right all the time. So there is a chance that we will make a conclusion and we are wrong. And there's two different ways we could be wrong. Type 1 error is when we reject the null hypothesis, but it was true. So it would be me looking at this first example and saying, okay, I have enough evidence to believe that the percentage has changed, but I am incorrect. It really hasn't. Okay, so how I remember it, it's an error, so we know we made a mistake, right? Type 1, we believe the H1. We believe the alternative hypothesis, but we were wrong. So we thought the parameter is not 6.62, but it is. Type 2 error is the opposite. We do not reject, but we should have. So it would be like in type 2, you conclude the null hypothesis. So it'd be like me looking at this and saying, you know what, the mean is still 3.25. But I'm wrong. It's really increased. All right, so shorthand variables for that, alpha is type 1 error, beta is type 2. Typically, we only really will do a lot with alpha outside of this section, but we will see it a lot. So what you really need to know, it's a mistake. So type 1, you believe the H1. You believe the alternative. Type 2, you believe the null. Alpha is sometimes called the level of significance. We will see that a lot throughout this chapter. And it's just how likely it is to make a type 1 error. So I want you to look at a couple scenarios and write what it would mean for each of these.
What if you say like on the mean one with the 3.25? What if you say that like it says it's going to increase? What if it decreased and you said?
Well, when we are testing this, what we're really going to do is test this one. And we'll either have enough evidence to believe that or not. So we won't be testing increase or decrease at the same time. Yep. Okay, so we want to give an example of what it would mean to make type 1 and type 2. I really believe the easiest option for that is to first write out the null and alternative hypotheses on these. So in 2008, the 62% regularly volunteered their time. The researcher believes it's different. So we've done that one before. We wrote it down on the previous slide, but we'll go ahead and write it here just so we know. The null, we said the p was equal to 0.62. The alternative was that it was different, not equal. So in type 1 error, type 1 says we conclude H sub 1, but we are wrong. So type 1 would be the researcher concludes P is not 0.62, but it is. Okay, so we are concluding the not equal to, but that was a mistake. It is in fact still equal to. Type 2 error. In type 2, you conclude the null. So the researcher concludes the P is still 0.62, but we're wrong, so, but it is not. Alright, why don't you guys take a try on the next one. See if you can identify what type 1 and type 2 error would be in this scenario. So null is that the mean is 3.25, the alternative is that it is greater. So type 1, which one do we conclude? Conclude the H sub 1. So the researcher concludes the mean has increased. Or you could say x bar is greater than 3.25, but you have to put in here it's error, so he's wrong, right? So we conclude it has increased, but it has not. Type 2 error is when we conclude the null, but we are wrong. So the researcher concludes the mean is still 3.25, but we're wrong. We should have gone with the other one. So, but it has increased.
Could it happen? Could it have decreased too?
We'll only test one thing at a time.
Okay, so it's just okay.
Yeah, so it's just whatever the alternative says. Okay. When we do hypothesis testing, last thing I want to mention is what we're actually proving. So we have a null, we have an alternative. What we are trying to do is find the probability that the alternative thing happens if the null is true. And so we're finding the probability that our call is greater than 3.25 if the mean really is this value. We are never actually proving the null hypothesis is true. So we are not accepting it. When we do this, we'll write a conclusion. We are never going to say we have proven the null hypothesis is true. Our options are either we have enough evidence to reject the null hypothesis, or we can prove that it's false, or we can fail to prove it's false. So we're not proving it's true, we're just trying to prove it's false. Okay? So I just want to show you what a sentence conclusion would look like. But our options are we can either reject or fail to reject. That's the only wording we can use. So we can reject the null or fail to reject the null. Failing to reject is not the same thing as proving that it's true. It just means I can't prove that it's false. I'm almost done if you want to have a seat. All right, so last example. According to a study published in March 2006, the mean length of a phone call was 3.25 minutes. Okay, so that's the one we've been doing. The mean is 3.25. The researcher believes it has increased, so the alternative was the greater than. So part A. Suppose the sample evidence indicates the null should be rejected. State the wording of the conclusion. So I do the stuff, which we haven't talked about how yet, but I find that I should reject this. So what we'll say is there is evidence to conclude. I'm rejecting the null. That means I'm going with the alternative. So the mean length of a call is greater than 3.25 minutes. I could say there's enough evidence to conclude the length of a call has increased. So if we reject it, we're rejecting the null. That means we believe the alternative. So we believe that the mean call length has increased. If we do not reject, have I proven that this is true?
No.
No, I am not proving it's true. All I'm going to say is there is not evidence to conclude the mean call length has increased. It doesn't mean I proved the mean was still 3.25. It just means I couldn't prove that wrong. I did not prove that it was greater.
For 2.1, would it say like there is not enough evidence to include the mean calling has changed?
Mm-hmm. All right, any questions there? So we are done with 10.1.